Hello everyone. So today we are solving another question of JEE 2020, the topic of laws of motion. So let's read the question. It says that they're given a uniform meter scale which is horizontally on my extended index finger like this, with the left one at 0 centimeter and the right one at 90 centimeter. When you attempt to move both the fingers in the center, initially only the left finger slips with respect to scale and the right finger does not. After some distance, left finger stops and right one starts slipping. Okay. XR from the center, that is 50 centimeter obviously, of the scale left one start. This happens because of the difference in the frictional force obviously. If the coefficient of static and dynamic frictions and the scale are this and this, so we have to find the what is the value of XR. Okay. So this question is only based on your imagination, because if you look at your pen, like if we start moving, so I can also feel sometimes that it automatically stops on one finger and starts slipping on another. So let's draw the free body diagrams, obviously, because this is from the topic of laws of motion. So let's suppose this is our scale. Okay. Now initially our left finger we'll consider it as left and this is as right. So initially my left finger is at here and applying some normal force of N1, and my right finger is at 90, which is applying force at N2. Okay. So it starts moving and stops after some time. Okay, so suppose when it stops, okay, now it was applying N1 here. This is the center, which is at 50. Now, if it stops here, then what are the conditions that should be true here? The first one is both are applying friction, so their friction should be equal to each other, cause like then it will start slipping on those. Second thing, the torque should be balanced. Torque should be balanced at like the from this point or any point, the torque should be balanced here. Okay. So we will write those two equations. Suppose it is at the distance of what we can write x1. Okay. So from the center, torque of this n1 is equal to n1 into x1, and we know that where n2 is at actually 40 centimeters from the center of mass. Okay, 40. So n2 equal to into 40 is equal to n1 into x1. Also, we know that what will be the forces here, as we know that left finger was in motion. Okay. So the friction applied by it will be N1 into 0.32. This should be equal to, and here it is applying the static friction, that is, it should be equal to zero point 0.4. So N1 into zero point 0.4. So from this relation, we can like if you divide and all, and this should be N2 divide. So you will get X1 is equal to 32. So it means when the left finger was moving and then it stops at 32 centimeters away from the center of mass. So now our new FBD will be equal to like this. So this is our 50 center. This is 32. Here it is applying N1. Now it says that our N2 starts and we have to follow the same condition, and it stops where it will stop at a distance XR from the, let me like confirm, XR from the center. Okay. So it stops at XR at the center from 90. Okay. So suppose it stops at XR. Now what happens? Again, we have to balance first their friction and first their and then their torque. So N1 into 32 will be equal to N2 into uh, XR. Now frictions applied. Now it will apply here static friction. So N1 into 0.4 will be equal to 0.32 times the N2. Again, if we divide, so we get 32 by 4 into 10 is equal to N2 by 32 into 10. So 4, 8, 10 and 10 cancel. Okay, I think, is everything fine? So 32 into 8. Yeah, so I think I made a mistake. Like there's, if we remove decimal of 32, it should be equal to 100 here. Now 32 into 8 by 10 is equal to the XR. That is, okay. Now if we calculate XR, it is nothing but 32 into 8 is 240, 256 by 10. That is equal to 25.6. This, I think this is our final answer. Let me write here. So XR is equal to 25.6. Thank you.